most of you at this point have become so proficient with your calculator that this will probably be a review for you. But let's look at how to solve a polynomial equation by using its graph on our calculator. So I'm going to start with the polynomial equation x cubed plus 5 equals 4x squared plus x. And we're going to solve this in both a very traditional way and in a slightly less traditional way using our calculator. The first way we want to do this is by rewriting this in standard form. So if I rewrite this polynomial equation as x cubed minus 4x squared minus x plus 5 equals 0. I have that rewritten in standard form. To solve this with my calculator, I can simply graph this by going to y equals, press the y equals button, and in y1 type in my equation. X cubed is equal to, y1 is equal to x cubed minus 4x squared minus x plus 5. I have that in y1. Once I have it in y1, press graph, and then second, the trace key, and remember up above the trace key, what does it give you? It gives me calc, and then I'm going to pick 0 on my calculator. So when I pick 0 on my calculator, I should find that it is pretty obvious that I have 3 x-intercepts on my calculator, and I'm going to do a left bound, a right bound, and a guess for each one of those, and I should determine that x is approximately equal to negative 1.09 for the first one, x is approximately equal to 1.16 for the second one, and x is approximately equal to 3.93 for the third one. Little squiggly equal signs mean approximately equal to. We're looking at decimal approximations and not exact values. Really nice for solving real life problems by finding those decimal approximations. So that is one way that we can solve by graphing. There's another not quite as traditional method to use our calculators to do the same problem, and that is to go to y equals, and without rewriting, in y1, put the left-hand side of the original equation. Put x cubed plus 5 in y1. And then in y2, in the second line, put y2 is equal to, and put the right-hand side of the equation, 4x squared plus x. Now, when you graph this, you press graph, we get a function that has a quadratic and a cube. All right, so I get something that looks like this, and then I get something that looks like this. All right, so real simple sketch here, but you should be able to find that on your calculator. Well, then what am I looking at? I'm looking for 3 x-intercepts here, and you may have to zoom in or out to find all of those intersections, because right here, is it really obvious I have 2 points of intersection here? Not necessarily. Or depending on how your window is set, some of these may be really hard to see that there are more than one. So I'm looking for a point of intersection where these two come together, a point of intersection where these two come together, a point of intersection where these come together. So on your calculator, second calc intersect to find those values, and you're just looking for the x values. And again, you'll get x is approximately equal to negative 1.09 for this first point of intersection. It equals 1.16 for the second point of intersection, and 3.93 for the third point of intersection. By graphing each side of the equal sign as a separate equation, you can solve that polynomial function by simply finding the points of intersection. So whichever one you find easier, graph them separately, look for the points of intersection, or rewrite this in standard form and find the zeros of the function. Allow you to solve any polynomial, regardless of how complicated it is, by simply graphing it on your calculator.